Hello, my name is Ashkan Iqbal, currently PhD candidate at the University of California, Irvine. My co-authors for this paper are Puriya Yaqini, Professor Nader Bagharzadeh, my advisor, and Misa Khayyambashi. It is our pleasure to offer you our article in which we have studied physical fault causes and their effects in 3D NOC design. In addition, we have also presented reliability analysis for each of covered physical faults, and finally we proposed a formal failure model for 3D NOC. So, a good question is that what is the necessity of doing this research? And in response, I would like to just add that, as you know, recently the new trends have been proposed by the researchers and scientists to follow the Moore's law for next generation of IC designs. And some of these ideas are listed in this slide that you can see. And for sure, 3D NOC is the only option as a communication infrastructure to support all of these ideas. In addition, the reliability of any new design is a major concern, which is the focus of this article. In this slide, you can see that we have categorized the physical level faults into three major groups, which are TSV issues, thermal concerns, and also the SE impacts. We have also presented the logic level fault models that any researchers in the same field they can use them to model these physical faults in 3D NOC environment. We have also investigated the sensitive components in a typical 3D NOC design based on the 3D NOC architecture that we have developed in Verilog in our lab, and we call it as DENAC, which stands for three-dimensional HDL emulator for NOC. And in case anybody is interested, they can just go to this link for downloading. In addition, we have also reported the effects of physical faults, which have been introduced in the previous slide, and you can just find them on the bottom of this figure. This information is useful for any researcher in the field as a kind of specific reliability metrics for 3D NOC design, such as the percentage of header loss or misrouting. As the other contribution of this article, we have also reported the failure analysis of major physical faults in 3D NOC components individually. One of these major issues is TSV to TSV coupling, which depends on current flow direction of a victim TSV and its aggressors. And consequently, we can conclude that TSV to TSV coupling is data dependent. The other important parameter is TSV configuration, which has been illustrated on the left side of this slide. With this knowledge, we have also quantified and categorized all the TSV configuration based on the magnitude of coupling signal noises, as shown in these tables. This analysis is also ended in reporting both inductive and capacitive failure equations, which are discussed in detail inside the article. We've also reported the failure probability caused by thermal concerns with the help of the concept of mean time to failure. As you can see with this equation, that the failure probability is a function of mean time to failure function. And what we did in the paper, we just tried to report the mean time to failure caused by each of the thermal concerns issues inside the paper. And finally, we provided the system failure modeling in terms of failing a TSV. So this model has different sort of inputs, as you can see in this slide, including the NOC dimension configuration or the injection rate, routing, the topology, and the failure rate of the TSVs. In order to evaluate the proposed failure model, we have run some simulation. In this simulation, we just made some of the parameters fixed, such as the topology, the routing, and also the NOC dimension. Then we run our simulation for various traffic injection rate and also the failure probability of TSVs. These diagrams are plotted in logarithmic scale. Furthermore, we just run the simulation and also we just use the failure model to find the accuracy of the proposed failure model. As you can see, based on the result, the maximum deviation of this evaluation is 8%, which shows that the proposed failure model is accurate enough. And finally, to conclude this article, I would like to just refer you to this figure that it shows that we presented the physical sources of faults in 3D NOC environment and the corresponding logic level of their fault models. We have also reported the effect of physical faults in 3D architecture, and also we reported the reliability analysis for each of these physical faults. And finally, at the end, we provided a 3D failure model in terms of failure of TSVs. And as a future work, we can just suggest that to provide an HDL fault injector tool, which is automatic and also based on the fault model, is a good topic of research, and also using more abstract and also the faster reliability analysis equation is another interesting topic. Thank you for listening to this presentation, and we look forward to hearing from you if you have any question regarding to this article, probably through the emails.